the unit 1. The unit 1, that is the diode applications. Under the diode applications, you will be studying the various topics such as half wave, full wave, bridge rectifier, and their analysis with the LC filters. So I will show you in detail. So unit 1, you will be having diode applications. You will be having linear wave shaping, non-linear wave shaping, special purpose diodes. These are 4 contents that relate to the unit 1. And unit 2, you are having the transistor biasing, FET and MOSFET biasing. And in unit 3, you are coming across single stage amplifiers. And unit 4, multi-stage amplifiers. Unit 5, FET and MOSFET amplifiers. So these 3, 4, and 5 is related to the amplifier, single stage, multi-stage, and FET and MOSFET amplifiers. So you can have a specific note of all these things. Unit 1, in simple, I have noted diode applications, linear wave shaping, non-linear wave shaping, special purpose diodes. And unit 2, you will be having transistor biasing, FET and MOSFET biasing. Unit 3, single stage amplifiers. Unit 4, multi-stage amplifiers. And unit 5, you will be having FET and MOSFET amplifiers. So in the previous class, you have come across the transistor part, you have come across the FET in BE, and you have not studied any amplifiers there. You have studied the rectifiers, and also special diodes. You have studied the LED and photodiode. But here, the respective diodes are different here, special purpose diodes. And apart from that one, you have studied about the digital part. The digital part is not in this one. There is a separate subject for you that is there in the 2-1. Okay. Hello. So anyone you respond till last ending of this class. Whenever I say, I can know someone at least you are listening to me.
Sure, sir. Okay.
Till the end, yeah, whenever I ask a question, at least you respond to that.
Okay, sir.
It will be clear to me that you are having no doubt recording this one.
Okay, sir.
So we'll come back to the screen here. So if you go for the unit 1 diode applications, these are the specific things. Unit 1, you can have the unit 1 contents, what are there. In diode applications, we are going to study about the rectifiers with filters. In the previous class, that is in the first year, first semester, you studied only for the rectifiers and its analysis and the respective parameters. But here in this particular syllabus, you are going to study about the filters, rectifiers with filters, that is half wave, full wave, and bridge rectifier, and their analysis with LC and LC filters. So you will be studying about the filters here in half wave mode, full mode, and bridge mode. Okay. Next is in linear wave shaping. We will studying about the RC network as a differentiator, and other is integrator. So this comes under the linear wave shaping. So in the lab also it is there, differentiator and integrator. Coming to the non-linear wave shaping, you will be studying about the series and shunt diode clippers. So here clippers are there and clampers are there. In clippers, you will be studying about series connectivity and shunt one. Series and shunt diode clippers. Coming to the clampers, that is a positive and negative clampers. And you will be coming across the clamping circuit theorem also. So in this nonlinear wave shaping, we will be discussing about the clippers. In clippers, two types, series and shunt clippers, and another is negative clamper. Okay, so this positive is there and negative is there. So you will be coming across the clamping circuit theorem. And the next topic is, in this one, is special purpose diodes. In special purpose diode, you are coming across the Schottky diode, SCR, tunnel diode, unijunction transistor. This is varactor diode and solar cell. Okay, Schottky diode is there, silicon control rectifier is there, tunnel diode is there, UJT is there, that is unijunction transistor is there, varactor diode and solar cell. These are the contents that are present in the first chapter. So one is rectifiers with filters, linear wave shaping, non-linear wave shaping, special purpose diodes. So we will go for the brief concept about these rectifiers. In the next class, we'll go for the filters. Just a minute. What is a power supply? So in the previous classes, you have studied the linear mode power supply. What for it is used? Hello, anyone? Just respond. Are you listening to me? Hello? Nobody is responding. Is it audible to you or not? Hello?
It's audible, sir.
Is it not audible to you?
It's audible, sir.
But nobody is responding to me. What for using the power supply?
It converts AC to DC, sir.
So we want to have a DC from AC. These
Yes,
things
sir.
we have studied in the previous class. I told you there are two types of power supplies, linear mode and switch mode power supplies. So we will be discussing about the linear mode power supply. I have specially explained all the terms that's related to the linear mode power supply here. Again, I will repeat the things. So if you want to have a stable DC voltage, so we will be going for the linear mode power supply. So in this linear mode power supply, we will be coming across three sections. So one is rectifier section. This is the rectifier section. Another is the filter section. Another regulator section. So these things you know now, already you have studied. Just I will again recall the things to you. So in this one, it is a circuit which converts the AC voltage into equivalent DC voltage at a required level. So whatever the specification is required, if you want to have 5 volts, you can have. If you want to have 12 volts, or if you want to have 24 volts, based on your application, you are going to design the power supply. So whatever be the power supply you are going to take up, so it consists of three sections. One is a rectifier section, another is a filter section, another is a regulator section. So in the last class, we have studied only the rectifier section. Okay. Yamma, rectifier chadivam manamu. రే మీరు స్విచ్ ఆన్ చేసి పడుకున్నారా ఎట్లా మీరంతా?
Yes, sir.
Yes, sir.
ఏమేమి చదివాము రెక్టిఫైర్ సెక్షన్ లో? వాట్ టైప్ ఆఫ్ రెక్టిఫైర్స్ యు స్టడీడ్?
Half wave rectifier, full wave rectifier.
Half wave, full wave.
Half wave rectifier is there.
Full wave.
Full wave rectifier.
Full wave rectifier is there.
Bridge rectifier.
Another bridge rectifier is
Bridge
there. Full wave rectifier with the center tap. This is also you can say this is a full wave rectifier. There is a bridge rectifier, and this is the half wave rectifier. Even మనం చదివాం కదా?
Yes,
I have given the
Yes,
complete analysis of this half
sir.
wave.
Yes,
I have
sir.
given analysis related to the full wave. I have given analysis to the bridge wave rectifier. So come to this particular block diagram here. Hope you remember this block diagram. So you are going to give the AC input to the rectifier. So the main purpose of rectifier is to convert AC to DC. Ona kada? AC to DC. What type of DC you are getting here? You are getting the pulsating DC. You are getting the pulsating DC. Ona kada? So pulsating DC means, what is meant by pulsating DC? అక్కడ ఉంది స్లైడ్ లో కూడా. It
Low
consists of
voltage.
unwanted AC components. మన intention ఏంటి? We have to have the pure DC. So this is the pure DC. You can see the waveform here. So this we are getting at the rectifier part. అవునా కదా? If you go for the half wave, only half of the signal you are going to take up. If you go for the full wave, whether center tap or bridge, you are getting the full wave. ఇక్కడ వరకు మీరు చదివారు, అవునా కదా?
Yes, sir.
Yes, sir.
ఓకే, మీ నెట్ కొద్ది స్లో ఉందా? Okay, now this rectifier what I told, this is a circuit which uses one or more diodes to convert AC voltage into pulsating DC voltage. This is the purpose of the rectifier. Now we go for the filter. What is a filter? Filter, it removes the ripple, or you can say unwanted AC components that are present in the DC, which is present in the DC. Which DC? In the pulsating DC. Pulsating DC lo manaku em cheyala? Unwanted AC components cheyala. So if you see the waveform here, then you can see the variation here. So it is almost nearing to the straight line, you can say. This is the obtained one, and this after the filter you are getting this type of waveform. Okay, next we go for the regulator. Regulator, this also you have studied. This also you have studied. Regulator is the circuit which maintains constant output voltage irrespective of the line and load variations. Line marna kuda load marina very kaapadu. So it is a circuit which maintains, this is the terminal voltage as constant. You want to have, suppose if you want to have the 5 volts output, so this 5 volts should be maintained even though if there is a variation in the input or load. Input voltage, input variation ante the AC input ఎంత ఉంటుంది? 230 volts and 50 hertz. ఇదే కదా మనకు AC. Yes or no? The line voltage is 230 volts. In some cases,
Yes,
it may be varying from 170 to 260. ఇంత వేరీ అవుతూ ఉంటుంది ఎప్పుడన్నా వేరియేషన్ వచ్చినప్పుడు. This variation should not make an impact on the output voltage. So that is called as the even if input voltage varies. Another is load current varies. Suppose if you are going to connect the load to the output, so it is designed to have for example 5 volts and 0.5 milliamps or 0.5 amps. Suppose if you are varying this current, suppose it is 0.4 amps or it may be 0.8 amps. So your load is going to be varied here, even though it should not make any impact on the regulator. So these are the things in this block diagram. What we have seen here is a rectifier. A power supply consists of a rectifier, a filter, and a regulator. Okay. Okay, ma.
Okay, sir.
Next we go for, before going to the filters. So filters on Monday's class will start. So first we go for the rectifiers. We'll recall the things in the rectifiers. Just I will close this one. We'll go back for the previous classes. Just wait. Okay, is it visible to you, this slide?
Yes, sir.
Okay.
Yes, sir.
Okay. So if you see here, already these things you have already mentioned. That is, rectifiers are of two types, half wave rectifier. So this is the full wave rectifier. In full wave rectifier, again, you are having using two diodes, another is four diodes. Now we just have a glance of this one, half wave rectifier with a transform input. So this is the half wave rectifier. Already you have studied, but in this class I want to just brush up the things which you already have studied in the previous class. So what is this one? What is this one? It is a transformer. Ona kada? This is the transformer. Hello.
Yes, sir.
So this transformer,
Yes,
you are
sir.
getting the required output here. So it is a step down transformer. This is a step down transformer. You are giving 230 volts and you are getting the respective voltage as per your specification. This is a single, there is no center tap, this one. So you will be getting, for example, 0 to 5 or 0 to 12, anything 0 to 18, anything you can have. So this calculation part, this is the concerned expression. That is, V2 is the output, V1 is the input voltage, N2 is the number of turns secondary, and N1 is the number of primary. That is, V2 by V1 is equal to N2 by N1. These things already you have studied in the previous class. So in this one, we have seen the operation. The half wave, this is a half wave rectifier. You are using only one diode and the load resistor RL. Input is given and the output is going to be considered here. So during this is the cycle of signal. So you will be getting only half of the signal here. Next half, that is 0 to pi, 2 pi to 3 pi. So pi to 2 pi, this is an off condition. Diode conducts during the positive half cycle of the signal. Yes or no? Half a
Yes, sir.
rectifier. Okay. So
Yes, sir.
these things we have
Yes, sir.
studied. That is, one pulse is going to have, that is 0 to pi to 2 pi, there is a non-conducting, this is a reverse bias condition, diode is an off condition. So for that, there is no conduction. So diode conducts across the various aspects here, operation of the half-wave rectifier we have seen. I don't want to tell all these things again. So these are the parameters what you have calculated, you have derived also. ఇవన్నీ చేసామో మనం లాస్ట్ క్లాస్లో ఫస్ట్ ఇయర్లో voltage current, maximum peak current through the diode, average of DC current, average of DC output voltage. So RMS
Yes,
current
sir.
you have seen, RMS voltage across the
Yes, sir.
load. ఇవన్నీ చదివాం కదమ్మా, ఇవన్నీ చదివాం. So AC input, ripple efficiency, ripple factor, peak inverse voltage, regulations, transform utilization factor, ఇవన్నీ ఫ్యాక్టర్స్ మనం ఆల్రెడీ లాస్ట్ క్లాస్ లో చదివాం. సో ఇవన్నీ మనకు అవసరం లేదు ఇప్పుడు. దీస్ ఆర్ ద థింగ్స్ దట్ నాట్ రిక్వైర్డ్ రైట్ నౌ. సో వి గో ఫర్ ద నెక్స్ట్ వన్, విల్ సీ. For the next class, you just go through all these parameters. This is visible.
Yes, sir.
Yes, sir.
Parameters
sir.
of your rectifier.
Yes,
Adena
sir.
slide.
Visible, sir.
Okay, okay. So these are the things. You just recall all the things. You take out your previous notes, verify the things, how we have done the analysis. So these things you just go through. So the calculation of this IDC for the half wave, that is IDC is IM by pi. So IM is nothing but VM by RF plus RL. This is the RF and this is RL, load resistance and forward resistance. And this calculation we have seen. DC voltage and average voltage given by VDC calculation. This is the VDC is nothing but IDC into RL. This is seen. VDC is VM by pi. into 1 plus RF by RL. ఇవన్నీ మనకు ఫిల్టర్స్ లో రాదమ్మా. ఓన్లీ థింగ్ ఈజ్ విల్ గో ఫర్ ద రిపుల్ ఓన్లీ. But you go through all these expressions before the for the next class. Before coming for the next class, these things you might have already done. RMS voltage, DC output power develop across the load. This is the regulation. Rectifier efficiency you are seeing. So what is the efficiency in the half wave rectifier? Half wave rectifier efficiency. Hello. ఎంతమ్మా ఎఫిషియన్సీ హాఫ్ వేవ్ కు
5 sir.
40.6. This is the efficiency you are getting in the half wave. If you
percent.
go for the full wave, it is going to be doubled. Okay. So next we will see other slide. Half wave rectifier, that is ripple factor chesama. Hello. Ripple factor
Yes,
is
sir.
visible to you? Ripple factor slide. Okay. So
Yes, sir.
these things we will be more concentrating in the filter concept. So this ripple calculation, in this ripple you will be getting 1.21. So you are getting this so this value you are getting. This ripple we are going to reduce in the full wave rectifier. In half wave it is 1.21. When you go for the full wave rectifier, it is going to be minimized. It is going to be reduced. So we'll see that one. So these things we are going to express here. These things are not necessary. Transformer utilization not there. And if you go for the filter concepts, okay. So we go for the next one, full wave rectifier. So we'll go for the full wave rectifier. It is visible to you, full wave rectifier.
Yes, sir.
Yes, sir.
You can have this type of circuit, or you can draw in another form also. So you can also, so this is a full wave. So you can also draw in this form. This is also can be considered. Okay. So in this operation, during the first cycle of the signal, complete cycle, 0 to pi and pi to 2 pi. So positive half cycle of the signal, D1 is going to be conducted. Negative half cycle of the signal, D2 is going to be conducted. This operation you have seen in the previous class. In both the cycles, the two diodes are going to be conducted. So you can have the continuous cycle of the signal. ఇదే కదా కంప్లీట్ పల్స్ వస్తుంది కదా మనకు ఫుల్ వేవ్ రెక్టిఫైర్ లో. దట్ ఈస్ దిస్ ఇస్ సెంటర్ ట్యాప్ ట్రాన్స్ఫార్మర్ వాట్ యు ఆర్ గోయింగ్ టు యూజ్ హియర్. సో అగైన్ వి విల్ గో ఫర్ ద రెస్పెక్టివ్ analysis. All the analysis part we are seeing in this one. So what are the factors I have mentioned in the previous slide? Those things you are again calculating. So what is the ripple here? What is the ripple? 0.48. Half wave length amma?
1.21. 1.21, sir.
Hello. Hello, dear
Yes, sir.
students.
Yes, sir.
Yes, sir.
Is it audible?
Yes, sir.
Sorry, net has been disconnected. Again, I made connected. So we'll come back to the subject again. So here, what is that I'm presenting?
Full wave rectifier, sir.
Yeah, just a minute. I will connect it. Just a minute. Be on the line.